So today we're talking about perfect squares. And perfect squares we see usually like a plus b quantity squared. If I wrote this out, it would be a plus b times a plus b. And you know you can combine, when I FOIL, I have a squared plus ab plus ab plus b squared, and this will auto combine to 2ab. And that stuff drops down. Likewise, if I have a minus b squared, quantity squared, excuse me, that gives me a squared minus 2ab plus b squared. And these two things are called my perfect square trinomials. Wow, that was a bad cue. Mainly because it was an S. Perfect square trinomials. There we go. And that's because they are the squares of binomials. So it's this binomial squared. Okay? So we've talked about this before. When we did FOIL, it was one of our special products. This is squares of sums, and this is squares of differences. What we're going to be looking at today is how to go from this line of stuff back up to the top by factoring. So, like, remember, factoring is the inverse operation of FOILing. So they undo each other. So we're going to go from this factoring back up to FOIL. So let's say, for example, we have 4y squared plus 12y plus 9. So I have a couple questions I need to ask myself when I am doing this. The first question is this. Is the first term a perfect square? So that means I'm looking at that 4x or 4y squared. Is that a perfect square? Then I'm going to ask, is the last term a perfect square? And finally, I'm going to ask if the middle term is either plus or minus 2 times where's multiplication? There. 2 times the squares, or what the square roots of the first and last term. Okay? Hold on. Let me figure out how to type this. So I'm going to type it a times c, but know that it's the square root of those things. Okay? So now I get to start answering some of these. Is the first term a perfect square? Well, let's see. 4y squared. If I took the square root of that, I would get 2y. So yes to number 1. It works. Number 2, is the last term a perfect square? If I take the square root of 9, I get 3. So yes, that one works. That means I want to know, is the middle term plus or minus 2 times 2y times 3. So whatever I got when I was asking if these were perfect squares, these answers are what I'm plugging in here and here. Okay? So if I multiply this out, 2y times 3 is 6y, times this 2 in front would be 12y. And I want plus or minus 12y. Well, I have plus 12y. So that means that this trinomial I have, 4y squared plus 12y plus 9, is a perfect square trinomial. Okay. Now, that's all well and good. I can define a perfect square trinomial. I know what one looks like. I can determine if one is a perfect square trinomial, that kind of stuff. That's great, but that's not quite our objective for today. Our objective is to find how to factor these. So, I'm looking at a squared plus 6a plus 9. And I will tell you that this is a perfect square trinomial. The question is, how do I know this without going through my sums and difference chart? Or some factors and sums chart. Well, I can do that, but I'm looking for a repeated factor of 9 that sums to 6. I can go ahead and make that chart, that's fine. Remember, I'm not going to start with like 9 and 1 because I want a repeated factor. Why repeated? Because I'm looking at something that's a perfect square. The easier way to do this is just to go ahead and take the square root of my a term and my c term. Square root of a squared is a. I have plus signs in the middle, so those are going to be pluses. Square root of 9 is 3. And if I did that on my factors chart, 3 and 3 are factors of 9, they sum to 6, that works. I plug them in here, that works, and it all checks out. And that's just dandy. Try this next one on your own. So what happens, though, if I have a perfect square trinomial with a minus b term? So you'll see that this is not a plus 8, it is a minus 8. So I can solve that the same way. I can take the square root of a squared, which will give me a. I can take the square root of 16, which will give me 4. The question is, how do I get that minus term in the middle when if I FOIL this, unfactor it by foiling, to get back up here, I need a negative middle term. So I would make both of these minus 4s. So a minus 4 times a minus 4. Now, is there an easier way to write this? Absolutely. A minus 4 quantity squared. And I probably should have done that up here. A plus 3 quantity squared. Okay, that's all.